email me later?
No, so we can post it on our club YouTube.
Cool, cool.
All right, I'm recording, so you can go ahead and get going.
Okay, guys, what is up? Welcome to my talk of Waking the Autopwner, because you know you have to have those edgy lyrics in my talks. So the first thing is, what is an autopwner? Does anyone have any? Can anyone tell me what that is? Hello? Okay, cool. So yeah, I'll just talk since no one wants to answer questions. So yeah, what an autoponer is you guys are familiar with the process of binary exploitation. It's effectively a tool that can take a binary, it can analyze it to determine various types of vulnerabilities, and then goes through the entire vulnerability research process to effectively give you an exploit. The autoponer that I made was designed for simple CTF channels. What I mean by that are CTF channels that, like by default, what they effectively do, they just scan input once, you run it, and it just does its thing. If you guys want, like I know this talk is mainly going to be about some of like the high level design choices I made. If you guys want to see like the nuts and bolts of like the code for like how I deal with various things, just like branch analysis, stack alignment correction, that type of stuff, it's all on the my GitHub repo on there, as well as like literally like hundreds of examples of it working. Now moving on, demo maybe I'll give the demo at the end. So first thing, um, can anyone tell me like effectively, like what would you do to make an autoputter effective? Like what are some of the major like design considerations you have to make?
Being able to trace your input and know where your input's going in your program.
Yes. Did you guys just hear Noop?
No, we couldn't really hear him.
Okay, you're you're muted, Noop. But yeah, like if you guys want, like if you'll just answer whatever you want. Like this talk, I kind of planned it to be a lot of like me asking you guys questions. So yeah, some of the major, probably yeah.
People answering the chat.
Oh, people are answering the chat. Okay, there's a chat functionality where like more chat. Okay, cool, cool. Okay, I see it. To extent a lazy, yes, auto poning is a lazy alternative to manual poning. Cool. Yeah, range of attacks. Yeah, range of attacks is one thing you have to consider. Also, large test cases. I know when I made this, probably the most critical thing I wanted to implement was redundancy, because the thing is with autoponer, well, with this problem, there's so many different ways you can make a binary and so many different ways you can just do stuff in assembly that the entropy makes it that it's not a question of if something will break, it's when and what you're going to do about it. So I've layered a lot of different things to effectively, if something fails, I'll have another mechanism in place in order to um, deal with that failure. And now it also goes to the large test case. You need a large test case to effectively identify those points of failure. Now, moving on, the oh god, this meme right here, it's great. Okay, yeah, so this autoponer isn't exactly like one tool. What it is it's sort of like 30 different tools that are or 30 different functionalities modularized into their own tools that's controlled and just issued in kind of this bag. Um, I made like probably like 12 tools to solve this problem. One thing I did do is I named all of the tools after a song. Uh, yes, it's cringy, I know, but just to go through some of the parts, Death Stranding, that's my static analyzer. I'm going to go through like all of these parts in more detail later. For now, I'm just listing all of them. Diamond Eyes is my dynamic analyzer. Solvay First handles exploit generations. Remenissions itself is just effectively a control module for everything else. Far Away, that handles exploit verification. SF, that's a payload generation API. And there's a lot more things that are encompassed into this that it uses. However, those are the main things. Any questions so far? Let me just check the chat real quick. Nice. Cool. Moving on. Okay. So first off, the static analyzer. So first off, can anyone tell me what is a static analyzer? Any ideas? Okay, no one's in the chat. Effectively, okay, you guys know like one way to find bugs in a code is to look at the source code. Static analyzing is sort of like that, where what you do is you analyze the code of the binary itself. Now, what I do is I use a tool called Ghidra to effectively give me a decompiled code, which they know what decompiled code is, right? Should I explain that? Okay, what decompiled code is you know how a compiler goes from like C code to assembly? A decompiler goes from assembly to C code. Okay, yeah, you know what a decompiler is. Cool. Thank you, chat. So effectively, it leverages Ghidra's headless analyzer, and what it will do is I've specified some wrapper functions to analyze particular functions like printf, gets, fgets, read, functions that if used in a certain way can introduce a vulnerability into the program. And what I effectively do is I will analyze the arguments to that function to determine, hey, is this a vulnerability? Is this not a vulnerability? Is this possibly a vulnerability? Something like that. No. There are advantages and disadvantages to doing that type of analysis method. Anyone want to take a stab at like what are the strengths and what are the weaknesses? I will give 10 seconds for the chat to answer. 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay. The strength. Well, some of the weak. Actually, probably the biggest weakness of it. It can do that. Yeah. Um. Thing is, it relies on having symbols for the standard function. So if it's statically analyzed and it's stripped, it's not going to be able to do anything. One advantage it will do, however, is since I have decompiled code, if that code is accurate, I can extrapolate knowledge from that. Like, let's say we have an fgets call that's a buffer overflow. I can trace where our input is, and let's say if we can reach other variables, I can trace where those variables are used. So like, let's say if we can overflow a variable that's used in a compare statement, we can effectively trace that and then do branch analysis, which is effectively like, oh, hey, here's a branch in an if-then statement. Which path do we want to go? And if you've ever done any like simple pwn for 50 challenge, that challenge is 9 times out of 10 going to be like you overflow an if-then a variable used in an if-then statement. So yeah, any questions? Also, for the record, Death Stranding, that's the name of the song from the game. Really, really crazy game, but yeah. Okay, no questions in the chat. I am moving on. I mean, the other reasons. Oh, my. Let's just take a moment to appreciate this. Okay. Okay, moving on. Man, they really beat this one up. Okay, so Diamond Eye is named after the classic Shinedown song. Effectively, what it is it's a wrapper for GDB Jeff. My bad when I was making the slides, I put GDB Peta since that was the like original GDB wrapper I was using. Do I need to explain what GDB wrappers are?
I think I've talked about that a lot.
Okay, cool, cool. You guys know it already. It's so nice having Owen right. But by the way, I'm from Owen's apartment right now. He's holding me. Actually, shouldn't be memeing about that on a recorded talk. So yeah, how does it work? It effectively wraps GDB, so it will run it in GDB and to do various analysis methods and sort of like fuzz it. Um, the strengths of it doing this way is by running it, doing it dynamically. first off, I don't have to worry about like in decompile code, one thing you have to consider is the possibility that the decompile code is wrong somehow. When you're actually running the binary, you're actually getting the real thing. So while your methods of analyzing what's actually going on might be wrong, what's actually happening isn't going to be false. And in addition to that, for instance, let's say that there's an info. And actually, let me check the chat real quick. There was like, for context, Ryan has not seen anything. Yeah, guys. Just for context, the one thing that makes me like presenting more is when I have people like meme up the slides beforehand. That way, when I'm presenting, I get the surprise of seeing some like really out there memes. Yes, it is quality stuff. But yeah, back to the dynamic analyzer. There are things such as like, let's say if there's an info leak that it's given, analyzing it through static analysis, we could just parse through the output and see, oh, hey, here's something like looks like an info leak. Check the memory mappings that is an info leak. Cool. So there are certain types of bugs or certain types of things that the dynamic analyzer is just better at, certain things that the static analyzer is better at. So having both the methods that are able to detect the same sort of bugs can help with the redundancy with being able to detect certain things. So moving on. Um yeah, anyone yeah, the reason why I have this okay, sorry guys, sorry. Yeah, so yeah, the reason why I have both static and dynamic analysis is yeah, so because just certain problem like let's say if just from how the setup of the binary is or on a particular function call or something like that, if static analyzer fails, the dynamic analyzer will probably have a good shot at like finding it or vice versa. So yeah, moving on. Okay, exploit verification. This is another very important piece of the redundancy. Now, one thing this autopwner will do when it sees like, oh, hey, it looks like there could be just a simple buffer overflow to a function attack. I'll get into that later. Let's say we have an exploit. We want to test to see whether or not it works. If that way we know if it works, okay, our job is done. Okay, it doesn't work, our job isn't done. We have more work left to do. See more things in chat. Best of both worlds. Okay, yeah. Um, how it works is I use GDB scripting and effectively just yeah have my own GDB script that's sourced into GDB, and literally when I just run the script, I just pass it a GDB command to invoke that script, which that script will just monitor if either there is an exeve syscall for BNSH or a few other conditions such as it's outputting a flag. It will then report back via file IO like, oh, hey, this exploit worked. Okay, I have to respect the crayons. So wait, first, this is just a Python 3 module for exploit generation. One thing it does have for every type of function attack that Remenissions has implemented, there is two different functions for implementing the type of attack in Solway Firth. One of which is for like a first try for an attack. The second one is actually for correction. Because what this autopwner will do, let's say that like it tries an attack for like let's say, oh hey, we try a buffer overflowed to a function in the pi segment, and that doesn't work. And all of our other first try attacks didn't work. I actually will cycle through all of the attacks and try correction, in which what the correction will do is it will try to cycle through some of the common points of failure to iterate through them. I'm going to go into more detail later as to exactly like for each attack, like how it works and like what it does for correction. But yeah, let me check for any chat questions. No chat questions. Okay, yeah, feel free to like ask questions in the chat or just like hop on the VoIP and say, hey, you got something wrong. Yeah. Moving on, Reminiscions. Reminiscions itself is just the Python 3 control module itself. It doesn't do any of the actual work. It just calls other modules to do that work or other tools to do that. It also makes a decision like as to like, oh hey, what attacks are we gonna do? SF, this is effectively a payload generation API, sort of like my own version of Pwn tools. Makes automatic exploit generation, actually like writing the exploits a lot easier since you can offload a lot of functionality, especially for like calculating format strings. You can do that at runtime and some other things. Okay, now let's get into a bit as to the exact like attacks that it can do. There are four main types of bugs that Reminiscions currently supports. Stack Overflow, which is just your traditional yeah, I'm pretty sure Noob has explained what a stack overflow is. An info leak, which what an info leak is when a piece of memory is outputted from the program, so you actually get introspection to the memory addressing of that program. Call input. This one I didn't initially plan on implementing, but I just saw too many CTF challenges with it not to. It's effectively when your input is called, a bit of a meme, but enough CTF challenges do it, so might as well have it. And then format string, which is where you get to control a printf statement and do some fun things with it. Now, in terms of the attacks that it can do, oh my, is that Chica or like 02 pretending to be Chica? Matt, are you here? I don't know. Okay, whatever. What a buffar attack is let, effectively it's where you get to overflow a variable, and then that variable is used in a compare statement, in which case it will either like go a certain code path in which you win the challenge, or go a certain code path where it won't. Now for this even though it's the simplest CTF challenge to solve like by yourself, it's not the easiest to automate. And the reason for that is for branch analysis, because you have to effectively determine like, okay, we can control a compare statement. Which way do we want to go? For that, what I currently do is back in the static analyzer, after I have found a bug and I notice, okay, these are the variables that I control with this right, and these are the compare statements that I can effectively control. Um, I will scan through both paths and see, oh, hey, are there any functions called in which case there's like, let's say there's a system with an SH called in one path, probably want to take that. Or another thing that it will do is as part of the static analyzer is it'll scan through all of the functions, much like how it scans for functions for vulnerabilities. It'll also scan through functions just like system or like fopen, for like fopen the flag and then read it and print it, to identify alternate win conditions. Because one thing that also um comes into play is the fact with you have to automate like what you know you're going to be able to do. So yeah, getting back to branch analysis, it'll scan both paths. If it sees like, oh hey, there is a function called that we're pretty sure will win us the will solve the challenge for us, we'll go that path. If there's one path that we see that it looks like there's like an exit function or a function that will cause us to lose it, we won't go that path. And if we can't tell either, we just pick one. Now, one thing about the branch analysis, as you can probably imagine, it isn't complete. However, by far, what's the most important thing that we model from that is effectively, oh hey, how can we turn it into like a binary statement? So like, if we input like OX5, it'll go one path, but if we sorry, I need to go back. Oh, oh my god. Sorry about that, guys. Let me go back to the slide. Dude, I'm a boomer noob. This is what happens when you let boomers present. Okay, present from this slide. Okay, back to me ranting on this. Okay, yeah, okay, yeah. What the by far the most important thing is when we're doing branch analysis is that we model the compares so that we know, oh hey, if we input this value in this way, we will go one path, but if we input a value in another way, we'll go a different path. That way, what it'll do is when you try it the first time, it'll go the way that we think it should be. However, if that doesn't work, we will literally just cycle through all of the various different compares until we win it. Now, one thing you might be thinking of is you think that that probably will take a bit of time. However, I have never seen a CTEC challenge like this that has more than like 5 compares, and that's still within a. It'll take a lot, but it'll only take like a minute to solve it. So yeah. Any questions so far? Oh, there is one chat. It's Chica. Cool. Okay, yeah, I was kind of like confused if it was like just Chica or like a 02 being Chica. Okay, moving on. Funk. This is by far the easiest challenge to automate. Effectively, what this revolves around is overflowing the return address via a Stack Overflow bug and then calling a win function. The problems here mainly with identifying the alternate win condition. For that being, like I talked about the alternate win condition functionality with the previous one, we'll look at common functions in which CTF challenges will use to introduce alternate win functions such as system bin sh or like some sort of like, oh hey, flag printing functionality or something like that. And we'll mark those. And in addition to that, if system itself is imported in there, we can also find the bin sh string. That's also, they could just flat out just call that and call it a day. Um, Also, another thing we have to worry about is if Pi is enabled, in which case we need a Pi info leak. We also need to have functionality for which we do for effectively determining, oh hey, this is the info leak, this is where we parse it out, and this is how we get it. How I can do that with both the static analyzer and the dynamic analyzer. Um, yeah. And for correction, one thing that comes into play sometimes it's ambiguous if a function is a win function. So sometimes we get multiple. So for correction, we can just iterate through all of the functions that we think are win functions until we get the right one. Let's check the chat real quick. No questions in the chat. Okay, moving on to the next attack type, Boff Shellcode. Oh man. Okay. Yeah, effectively what this relies on is using a stack overflow bug to overflow the return address to point to shellcode on the stack. Like the previous challenge, except, well, thing about this versus the previous challenges, this will always require a stack info leak. However, the process of getting that info leak is relatively similar to the last one. A few design things that you need to consider is the fact that and for all CTF challenges, you are going to need more than like one pair of shellcode. For one particular challenge, you might need some that's like really small. For others, you might have certain input constraints, in which case certain bytes of your shellcode aren't really feasible. So what I'll do is I have like 10 different shellcodes for both x64 and x86, which I will effectively cycle through for correction. Yeah. Any questions so far? Yeah, what's up?
Is all of the shellcode like NSH system shellcode, or do you have functionality for like
Oh no, it's all just to call Ben SH. Yeah. In case you guys didn't hear, Noob had a question if all of the shellcode was just to spawn yeah, spawn a shell, or if there is some to like read and write to a file. Currently I just have it where it just spawns a shell. Yeah. Also, another thing that you sometimes run into with the previous two challenges is there will be a compare statement to get to like a return or something. So branch analysis never really goes away at all. Moving on to the next one, this is a bit of a meme challenge type, but I implemented it anyways, call input. It's for when your input is call. There's a few CTF challenges like that. To detect it, I just have it done just in this dynamic analyzer, which it just like looks, okay, there's a segfault, it's executing instructions. These instructions are from our input. Okay, model the bug and file the exploit. For correction, it's sort of similar to the BOF shellcode where it just will cycle through different shellcodes until it works. Yeah. Yes.
Do you do like pattern generation to determine which parts of input is on?
Yes. Yeah. You've just asked a question if there's like pattern generation technique used to detect that, and I said, yeah. I'm pretty sure I implemented myself. However, no GDB, Jeff, and PETA have their own pattern generation thing to do that. Yeah. Any noted questions in the chat? Moving on to the next type. Return to static. Okay, this is effectively, this type of attack is for when you have a statically compiled binary um, without pi. So chances are you'll be able to just overflow it and then pull gadgets from the binary to make your own exCVE Bennis H call. So yeah, that's just what this attack type is for. Um, I know for like I didn't past like having it be able to solve like the first DEF CON speedrunning challenge from a few years ago. I didn't implement a lot of like functionality into this one because I just I saw more CTF challenges in other categories, but yeah. Now we start to get to the fun challenges. Return to libc. Should I explain what a return to libc is? Okay, yeah, return to libc. It's like a lot of those all early challenges where you're overflowing the return address. However, in this case, you're returning to code in the libc segment. So what the libc is you guys know functions like printf, puts that you just call and kind of expect it to be there. They are from the libc, which is the linked int, so you don't have to write your own versions of those functions and have to deal with a copy of it. Um, so for this one, the challenges a lot of times are like, okay, do they give us the libc info leak? Do we have to get that info leak ourselves? Um, right now, this Autopwner does have a method of automating the process of retrieving that info leak via a call to puts. How are we doing on time? Okay, almost over time. Sorry, guys. Um, yeah, it will use the just the classic like puts call it under the GOT function to output a libc address and use that, and then just call main again and cycle back. And then in terms for how it will actually return, I should have a chat. You can go later if you need. Cool. Yeah. In terms of what it will do after it actually has a libc address and ready to actually return to it, if it is a 64-bit binary, it will cycle through all of the one gadgets it has. In addition to that, it will also try to just return to Bennis H with just pulling gadgets from the libc. For x80 for 32-bit binaries, since one gadgets are a bit harder to implement, it will just try and return to just a call to like system with like a yeah. Moving on, remote libc ID. This is probably the most beneficial attack method that this has, and effectively what this is, it's a return to libc. However, what it will do is it will ID the libc version of that is actually running on the target, because the thing is there are many different types of libc, as you guys probably know. and if you don't know the version of it, you can't do that sort of attack. So how this does it is it uses a tool I made called the Knight, which effectively also the Knight is based off of um ellipse database somewhere. It's not my idea. I just like wrapped it into like a nice Python module API to call. Um, yeah, it will leak two addresses from a binary running on a server from somewhere, and it has to know what those two addresses, what the symbols are for it. And by knowing the offset for that, you can compare that against a lot of different libc versions and identify, okay, chances are it's like one of these, it's probably like this libc. And then from there, with that libc version, you can go ahead and launch a return to libc attack. Now, the reason why this particular method is so great is it's an unintentional solution for a ton of challenges. Now, granted, if it's an unintended solution, it's probably overkill. It's probably a much easier way to do that. However, since this is automated, we're not doing any of the work ourselves, and a lot of times that easier method, it can be kind of tricky or like a one-off thing that you wouldn't really have implemented. So it's a nice backup. I know like there's a CTF called like 24/7 CTF, and I think this got like 4 of the challenges, and all of them it got like because of a unintentional solution where this is what it used. Now moving on. Okay, I need to read this when mom says no more pasta. Sorry. What? What is this? Oh, what is this? Okay, okay. So yeah, format string, which is effectively when we can control the, yeah, it's when we can control the printf call made, and we can either leverage that to get an info leak, we can leverage that for a write, we can leverage it for that both. One thing I kind of went a bit overboard when I was implementing format string attacks. There's like, I think like 15 of them or something like that I implemented. Won't go through all of them, but the major variations, I included format string functionality to both leak and yeah, get leaks from including the stack, libc and pi segments. And in addition to that, I have format string exploits that effectively attack all of those. So let's say if you want to like write over the return address or a GOT address of a function that's called later on to like, let's say a pi segment, or you want to overwrite the return address to point to shellcode on the stack, or let's say you want to do a GOT overwrite to, let's say, a one gadget. All of that was implemented. Um, a bit about how, yeah, cool. Any questions in the chat? Cool. Okay, next. Hey, does your girl have a twin turbofan? Oh, that's a fetch. Okay, okay, nice meme, nice meme. Okay, now I'm gonna share one thing. I'm gonna briefly, hang on, testing. Oh, that multiple share redundancy, that's part of the demo that I'm about to do after this. For test. I don't know who that guy is, but he looks happy. I'm happy that he's happy.
It's John McCain.
John McCain?
Yeah.
What? Okay, I'm not gonna quit. I got one thing in chat. He's not happy. Okay, okay, okay. Well, I hope he gets happy. For testing, I implemented like 2 really types of test: unit tests, which are like individual binaries I created to test various functionalities, and CTF challenges, which were CTF challenges used in some CTFs that everyone got and tested against. All in all, there's probably between like 200 to 400 tests, like 105 of them being CTF trials and the rest being unit tests. If you want, there's a link in my repo to like where all those challenges are, along with the exploits it generated with them. If you don't believe me or anything. What? What is this? What is this? Okay. Okay. Any questions before I try to demo this? Uh,
Will the demo work?
it worked 2 hours ago. So yeah, let's do this. Cool. Exit full screen. Cool. I'm gonna try sharing my VM. Let me just pull it up. Participants, new share. Okay, can you guys see this VM?
Yeah, we can see it.
Okay, cool, cool. Let's go. Let's go here. Pick a CTF challenge, someone. Can you guys see this? No, I'm doing Seesaw Pilot. Oh wait, no, five. I saw five more. Yes, yes. No, you. Our chat is the actual worst. You don't know if you can put this on the glove YouTube. If you want, Claire, I could change that from an I don't know to a definite no. If you want.
I can make
Okay.
it unlisted, so only certain people, like only people with the link, can see it.
Okay, so that way it can like definitely be used to blackmail me. Got it. Okay, so here we have. If you guys have heard of Seesaw, this is a challenge that came out in 2017, which I don't know actually. I came out some years ago. I'm not going to think of how many years it came ago. Um, yeah, it's a Battle for Level 4 challenge. You can see it run like this. Segfault, and let's try running this Autopwner. More, some. Okay, we see it right now. It's running the static analyzer. It's going. It's going. It's going. Okay, it models it. Oh yeah, I think right now. Okay, tried it. Okay, I found the info leak. Probably will be able to put it now. Yeah, this is one of the instances where the info leak is kind of hard for the static analyzer to find, so it has to wait for the dynamic analyzer to come in, find the bug, and it's generated exploit buff shellcode, which we see this verified exploit, and we run it, and we see, okay, it was able to successfully generate an exploit which solved that challenge. I know. I'm not sure. I know, like, it also solved a challenge from the Seesaw that just happened a few years ago. Not a few years ago, like a few months ago. It's October, yeah. It's actually kind of funny since I was like, I know when the teams we were competing against literally heard that I solved it and then like used it to solve it. But yeah. Let me check the chat for any questions. Chat. Jocelyn really tried.
There aren't any questions.
Okay, cool.
That.
No. Let's. Yeah. Do you guys want to see more demos, dig into the code, or call that it? I will let the chat decide. Oh, I did. Yeah, I'll run it again. You guys just saw the exploit working, chat.
I mean, we saw you cat the file, but
No, like this. Look here. I just ran the exploit it generated. Yeah. Cool. Yeah. Here, I'll do one more.
Are there any format strings?
Oh yeah, there are format strings. Here, I'll show you one. Noop wants to see a format string, so I'll show him a format string. Uh, actually, isn't there? No, there wasn't one. This it doesn't have one of the red pwn challenges. Okay, let's go to Tamu. So let's RM tech RF. Actually, I think this. Give me 1 second. Yeah, let's do this one here. So let me just get rid of the existing exploit so you know that there's no funny business going on. Exploit. This might be an older version of Remenissions though, so might not work. Give it a second. Okay. And it generated that. Python 3 verified exploit. And okay, I was able to generate. This challenge, what it will do is it would read out the flag. And one thing and since if you're running that locally, you need to have your own copy with the flag. So what I would do is I would just generate my own copy of the flag.txt. That's where the flag without them we equal nothing, more edgy lyrics. And you can see like that's the actual contents of flag.txt. So by running it, it will read the contents of that flag file. Yeah. Anything else you guys want to see? Let's see. We have one thing in chat.
Can we run this
Yeah, what's
against
up?
remote services?
Okay, Noob just asked a great question. Do I plan on adding heap functionality? I wouldn't be opposed against it after I get done with like my current or maybe one or two more projects. The main issue with heap functionality is all like the 100 CTF challenges I solved and all of the unit tests and everything. They all have a similar input format where it's just like by default I send it just input once and yeah, that's it. I can maybe call in like mannequin or do more hackery so I get additional inputs, but by default that is it. With a heap challenge, you have an actual like a menu that you have certain functionality where you need to effectively identify and model that functionality, which that can be done. However, it would probably require a lot of work in it, modeling that input and then having a system that could deal with that. Not saying that it could definitely be done. It's just within the time frame I had to work on this, I didn't have that. So yeah, would be 100% down to make that if as long as I get the time for it. Yeah. Any other questions, anyone? Cool. Well, thank you for hearing me rant for like an hour. I'm gonna stop sharing.
Thank you, Ryan. We appreciate you giving this talk. I have a quick question. Are there any design decisions, if you could go back and like redo it, are there any decisions you wish you would have made differently?
I know like this is one great question. Probably the biggest design decision I would have made is implement good coding practices at the start. The original code base for Remenissions, like while it did work, it was like just god awful. So I had to spend a lot of time just like going through like re-implementing all the like functionality with like good programming practices, like with OOP and everything. Which that took time, and then testing it after all of that took time. So yeah, I wish I would have just implemented good coding practices from the start.
All right. Are there any other questions for Ryan? Thanks for answering, by the way.
No problem.
All right. I think there's no more questions. So thank you so much, Ryan, for giving this talk for us. We really appreciate it. It's not an area we would have been able to get exposure to any other way. As far as I know, you're the only person who has an autopwner that's willing to talk to us. So I think it's really cool that you've been working on this project and making it open source. So thank you for explaining kind of your decisions that went into it, its functionality, and giving a demo for us.
Okay, cool. Yeah, thank you. Again, if you guys want to like look into it more, I posted the link to the repo in the Discord. Yeah, there it goes into a lot more detail as to exactly like how the actual like nuts and bolts of it operate. But yeah.
And as you guys look at the code, if you have any questions, you can always harass Ryan in our Discord and ask him those questions. So he's an available resource to you.
Yeah, just when you mess, feel free to at me, but like do it in a channel. Don't DM me, please.
And then Owen asked you why DM versus, why at in a channel versus DM.
Okay. Apparently a bunch of people asked. The thing is, I'm pretty sure there are people in here that aren't friends with me on Discord, and because so many people like, I just sort of got like flooded by DMs by people I don't know. I just sort of oh no, not flooded, but like I don't like it at all. So I like disabled that on Discord. My God, there's no way I can say this without sounding like a jerk. Yeah, like I'm 100% down to answer questions, just like, yeah.
Yeah, a good spot for further discussion about the autoponer would be the general poning channel. I think that'd probably be the best place for it. Unless, Ryan, you have a different preferred channel.
Literally just like whatever channel, like, yeah, just, yeah. If you want my attention, just at me.
All right, well, I think that kind of wraps up the end of the talk. If anyone has any further questions about events that are coming up with the club or any further questions about Remenissions, feel free to reach out to myself or Ryan based on what type of question you have. Thank you so much for coming out this week. We really appreciate it.
Cool, no problem.
All right, have a great week, everyone.
How are you doing, guys?
Have a good one.
Hi, everybody.